meantime, the presentation starts. Let me first introduce myself. I am the heading the Department of Environment in ONGC, and I have got a team of environment engineers along with me. And basically, we look after all regulatory clearances as far as our exploratory and development projects are the drilling and production facilities are concerned. So we obtain basically wherever it is required, like if you start doing this exploratory drilling or development drilling, and if then the first and foremost thing is we need to obtain terms of reference from the Ministry of Environment, Forest and Climate Change. Based on the terms of reference, I mean basically they gives a yardstick through which you basically undertake environment impact assessment studies. And those study means that includes both, there are many things like this includes all air quality monitoring, then water involves both underground water, surface water, then if the nearby water bodies are there, that also has to be seen, then noise, biodiversity assessment, I mean the area where we want to carry out our EN operations. So those area has to be also assessed with regard to the biodiversity, because see biodiversity basically this tells about the variety of species that exist in a particular biome, in a particular area. So whatever activity, I mean whatever the human interventions are there, we have to ensure that the biodiversity of that particular locality does not get disturbed. So these are the few things that we have to undertake. All these assessment and meteorological studies are also taken. So these are different studies are part of the environment impact assessment. That is done by generally credible agencies which are already accredited with the Quality Council of India or NABET. NABET is National Accreditation Board for Education and Training. So they have to be accredited, I mean they have to be accredited from the Quality Council of India, these consultant who prepare these environment impact assessment reports. So they have to be by this, so that the only, I mean the main thought behind this is that these quality reports, I mean even environment impact assessment reports, these reports should have a quality outcome and should be able to capture all necessary data so that it can be used further by the ministry. So this environment impact assessment report is done, and then after this again is submitted to the State Pollution Control Board, I mean the state in which it falls, and then the concerned stakeholders who are there in those areas, I mean see if you want to carry out any operation in a particular locality and falling in a district, so what happens, we have to do a public hearing. Public hearings where the stakeholders, I mean if it is the whole district is, if the whole district, it falls in the district, then the all stakeholders, I mean the community people, the education and all the government bodies, they come together, we have a discussion. I think that is led by, earlier it was used to be chaired by ADM. Now I think the rules have been relaxed, now it is being chaired by the SDM. Because the ADM again have been very busy, so in order to relax and to do the things, so these are the few things that have been undertaken, interventions have been undertaken by the Ministry of Environment, Forest and Climate Change to ease of doing business. So I'll start with the presentation, and in the meantime if you have any question, your questions are most welcome. See, the topic of today is marine environment response, planning and preparedness. The first and the foremost thing that we need to comprehend is how marine ecosystem is important for all of us. I mean until or unless you understand the basic facets, all importance, what are the different systems that are there in the marine ecosystem, you will not able to appreciate it. And the first, I mean let me tell you, the oxygen that you breathe, 50 to 70% oxygen comes from your marine ecosystem, not from the terrestrial land. Please remember this. So if you do not take care of this marine ecosystem, See, the very existence of human, not only humankind, even the other creatures are also at a stake. So see, there are certain facts which I wanted to point home to you all, that ocean covers almost to the tune of 70% of the total Earth's surface, and 97% of the water that is there lies in the ocean. And then, as far as the different creatures that are involved, that almost to the tune of 99% creatures, I am talking about the total population of all different kind of creatures, 99% exist in the marine ecosystem, in your oceans. So see how important it is there to keep the healthy system. So as I have already told you, this produces almost 50 to 80% of oxygen that we breathe. Then the most important, again, see, you have been reading a lot of late also, and I think for the last 10-15 years, global warming. And global warming main causative factors is the increasing emission of carbon dioxide. So this particular marine ecosystem is an excellent carbon sink. Carbon sink means this is the best reservoir which can absorb carbon dioxide from the air, in comparison to, I think you must be reading terrestrial forest, these all forest covers, forest and tree covers. But as far as the capture is concerned, mitigation of carbon dioxide from the atmosphere, that we say sequestration. Sequestration, carbon dioxide means whatever the carbon dioxide is there in the Earth's atmosphere, whether it is anthropogenic means which is with the natural setting, natural system. Plants breathe out, human breathe out. So these all carbon dioxide that is excreted through all these systems. So these are all basically anthropogenic. So as far as the anthropogenic concern, marine ecosystem is sufficient, I am telling you, is sufficient to cater to the requirement of sequestration of carbon dioxide. But now the question is, now human, in the name of development, we have, if you see that because of the greed, the level of comfort we like to have, so because of all this greed and comfort, and that is all through the uses of energy. That is again energy has to be at some cost. So uses of fossil fuel, whether it's a coal, crude oil, or any natural substances. So all these things, when we burn all these fuels, so basically carbon dioxide is emitted in the Earth's atmosphere. And these marine ecosystem, now I'll explain you in the later slides how this marine ecosystem as such, how it acts to fix this carbon dioxide which is there in the Earth's atmosphere and absorb this as a carbon. And plus, because of this excessive carbon dioxide emissions that we do because of our activities, this has led to the acidification of ocean also. I think you must have read, I think also, water plus carbon dioxide leads to carbonic acid, H2CO3, isn't it? So these, once you have more and more carbon dioxide dissolution in the ocean or sea water, that will lead to the more and more formation of carbonic acid, and that will lead to the acidification of this. Now see, again, the most important thing we need to understand, when we do this, when acidification is there, it's all marine, all marine creatures and the different kind of ecosystem, which is the part of the larger marine ecosystem. I'll talk about that also. Marine ecosystem as such is a larger set of ecosystem. That also includes a number of subsets of ecosystems like lagoon, seagrass, seawood, mangrove. So these are the important subsets of ecosystem which play a very important role in sequestration of carbon dioxide. Not only carbon dioxide, it also helps in whatever the drainage, city walk drainage, all these. These mangroves, I think they are the excellent sink for these all drainage system. So as I have told you that it almost captures to the tune of 30 to 70% of the global carbon dioxide produced through anthropogenic sources. And as you must be knowing, this is a very critical component of the global food system. I mean, human beings are relying more and more on the marine creatures, fishes, different kind of fishes and all that, and that has become a part of the global food system. Then another very important beauty of this marine ecosystem, it's a very good sink of heat, excessive heat that is generated. It's a very good sink. It almost absorbs to the tune of 90% of the excess heat. Then, which I have been telling you time and again, this oceanic ecosystems are very efficient and almost to the tune of nearly 200 times more productive than the terrestrial counterparts in mitigation of this all carbon dioxide sequestration. Now, I just wanted to share you the overview of different kind of ecosystem that is part of the marine environment. So that, see, until or unless you understand that these different components are such, you will not appreciate, how badly we are impacting our marine environment. So, and these all different subsets of these ecosystems again play a very important role in offsetting all this. And whether it is oxygen, maintenance of oxygen level in the atmosphere, or reducing the carbon dioxide that is there in the system, in the Earth's atmosphere. Then this different kind of pollutants, the city drainage, all these are taken care by these different subsystems, these subsets of ecosystem. So the first and the foremost I have taken is the mangrove ecosystem. See, this basically occurs in the intertidal region between main sea level to the high spring side. This serves as a buffer between marine and terrestrial communities and protects shoreline damage from wind, waves and floods. See, this basically acts as a bioshield. Through this, because these are all deep rooted in this, and once any kind of storms or any kind of things that they are able to sustain these different kind of storms. So that is the beauty of mangrove. Then another beauty of mangrove is that it has got a very high salt tolerance. And often among the first species, mangroves are supposed to be the first species to colonize mud and sandbanks flooded by seawater. So they fix these two also things. And you will appreciate the fact that if we plant mangrove in an area of 1 hectare of land, that will lead to the sequestration of 1100 tons of carbon dioxide. See the beauty of mangrove. And when you compare these with the terrestrial forest, the forest and tree cover, there on the land, see, this is a much more efficient in comparison to them. So that's the beauty you have to understand, and you have to basically understand the comparison between what is there on the land. See, why I am telling all this, see, we often talk of plantation, undertaking plantation, we do take lot of plantation, but then see, Sharmaji has told this particular underwater is a sustainable development goal number 14, and you will be surprised to know this being the main source of our oxygen level, still United Nations have not funded appropriately to cater to the requirement of this marine pollution. So this is a clarion and an urgent call to everyone to understand that we need to upkeep the health of marine system, marine environment. Then another subset of this marine ecosystem is the coral reef ecosystem. See, these are also again supposed to very fragile ecological fragile environment of the globe. I think you must have been reading also about the coral reefs. How coral reefs in the western offshores have been badly affected. Then See the percentage of area that it covers is almost to the tune of only 0.2%. I mean, it's a very decimal kind of percentage there of the total area of ocean. And see the role that it plays. It is only 0.2% and it supports highest level of biodiversity on the earth. See the beauty of coral reef. And almost house 25% of all marine creatures. See 0.2% and supporting biodiversity and 25% of the marine creatures. See basically why I have put all this information just to make you understand that it's not that small ecosystems are also equally very important. We need to nurture them and we need to first understand what is their importance. Until unless you understand their importance, you cannot nurture. You should develop a sense of doing something, contributing something meaningfully towards these ecosystems. Then this is very good in absorbing wave energy also, and they contribute in the coastal, reduction of the coastal erosion also. Now the another subset of marine ecosystem is estuarine ecosystem. This is also very important. This is basically processing of riverine and coastal carbon plays a disproportionately larger role in the global carbon cycle relative to the small aerial extent of the estuarine environment. And this sediments, sediments of this estuarine is almost, it can store 10 times more than the sediments in the forest. Whatever the sediment, I am talking about the soil sediments, soil and sand sediments. So estuary sediments are much more efficient, almost 10 times more efficient than capturing this carbon from the earth atmosphere in the sediments in comparison to the sediment that is there in the forest area. And I just added this, basically estuary or estuarine ecosystem is known as the nursery of the sea. See, you have seas, a lot of nurseries. You must be purchasing a lot of plants from the nurseries. So this is basically estuary, nothing but it serves as a nursery for the sea. Next slide. Then another subset is lagoon ecosystem. This is again shallow water bodies lying in low-lying coast connected to the ocean by one or few restricted channels or inlets. Now this also system, lagoon ecosystem also supports a very high biodiversity, productive ecosystem and provide a wide range of natural functions. And this is known to provide a number of ecosystem services to all the communities that live nearby. So it has got a very important economic activity role also, this lagoon ecosystem. Then again, this lagoon ecosystem is often threatened because of these all pollutions from the industry, sewage, dumping of city sewage, dredging. Dredging is basically removal of all sands. Continuous removal of sand from the particular locality, that is known as dredging. So the expansion of urban and rural settlements also cause a lot of disturbance in the lagoon ecosystem. Then comes another seagrass ecosystem. In this seagrass ecosystem, basically this pertains to the monocotyledons. I think you must have read monocot and dicot. In class you must have read that. Can anyone tell what is the difference between the monocot and the dicot? I think I have also read in class 7th, 8th in biology. Anyone? What is the difference between the monocot and the dicot? I think this is all, you all must have read in 7th and 8th, biology. See, monocotyledons are basically a plant having leaves where you will not have lot of veins. It will have a only unique, it will have just mono kind of system. So the whole leaf as such is a plain and simple. Whereas in case of the dicot system, there are a lot of veins on the leaf and leaflets are there. So this is the difference between the monocotyledons and the dicots. So what basically seagrass ecosystem is basically a monocot system, and it is found submerged in the shallow and the sheltered localities of sea, gulf, bays, backwaters and lagoons. And around 14 kind of species are reported along the Indian coast, and almost 9 species are found in the Andaman and Nicobar. Again, Andaman Nicobar is a very important region of our country, and you all must, I think many of you must have visited Andaman Nicobar also. There also system, because of a lot of tourism and all that, that is also being developed, so that also needs to be protected. So that has again a good number of species in the Andaman. It's almost 9 kind of seagrass types are there in this. Then this again occupies only 0.1% of ocean surface, but stores up to 80% of carbon dioxide sequestration by the ocean. See the beauty. So less area and so much important role they play. And twice the amount of carbon per hectare as the when you again compare with the terrestrial soil, the soil which is there on the land side. In comparison to that, this again seagrass soil or sand, again they have got a better potential to do carbon dioxide sequestration. Then I think probably last that I am dealing this seaweed ecosystem, because this has got a very important in the sense it has got a lot of medicinal values. Lot of high rich nutritions are there from this seaweed ecosystem. So it's mostly found on the flat and the rocky coastal wetlands, and summers during the high tides and get exposed during the low tides. I think you must have seen also, they have a lot of programs there also on the seaweed ecosystem. I think probably I also used to see the Living Planet maybe when I was in 11th or 12th. So I used to see some of these things, and those things really always attracted me, always fascinated me. And probably if you happen to watch, please do watch, and then you will be able to understand in a much better way. You will appreciate these things in a much better way. Then incredibly efficient, it is again excellent in sucking carbon dioxide. See, seaweed ecosystem again very good in sucking carbon dioxide that you generate in the Earth's atmosphere. And this again, this carbon dioxide, excessive carbon dioxide that they take. Now, can anyone, I think you must have read the photosynthesis. How do they, how they generate oxygen? This through the process of photosynthesis. I think this is a very basic question. Anyone? I want from the student community. Can anyone explain how oxygen is generated by these plants or these ecosystems?
It's very simple.
So by absorption of sunlight, when sunlight plants have lost sunlight, they create.
What is that pigment?
The pigment.
Chlorophyll.
Chlorophyll. And see what happens. See, whatever the carbon dioxide that you release in the atmosphere, those carbon dioxide plus water along with the sunlight, in presence of, see, again there are two things, aerobic and anaerobic. And then in presence of sunlight, they synthesize glucose. This CO2, 6 molecules of carbon dioxide reacts with 6 molecules of water and leads to the formation of glucose moiety, C6H12O6. Plus, it releases energy in the form of ADP, ATP, adenosine diphosphate, adenosine triphosphate. I think this is all we have read in class 8th, 9th. But then you should try to analyze and link these things when I am saying that how these different kind of ecosystems are responsible in fixation of this carbon dioxide. How these ecosystems absorb carbon dioxide, grow themselves, and in that growing those species, they generate oxygen that oxygen we breathe. And so, just summing up all this, Again, I'll see it is very important for all of us to understand that when you talk about all these ecosystem, we can only safeguard this ecosystem. We can safeguard and will continue to safeguard this marine environment. Why it is required to save? Because see, there are the 5 most important emerging climate crisis issues, climate change issues that we are getting plagued by. Can anyone throw some light on this? What are the different, 5 most critical impact of climate change? Where marine ecosystem plays a very important role. See, the first thing is the rise in the sea level. See, because of this global warming, we are going to have rise in the sea level. The moment we say the rise in the sea level means low-lying areas are going to be submerged. That means more and more area of land is going to be submerged. Then the availability of land for the inhabitation, whether inhabitation means inhabitation for the humankinds or the other terrestrial creatures, will keep on decreasing. Even your economic activities, your ports, all are going to be hampered because of this, isn't it? So again, the first sea level rise is one of the very bad impact of the climate crisis or the climate change. Then another is, you must have seen, there have been an increase in the instances of lot of storms in the sea, in the ocean. You must have heard of typhoon recently. There in the Tokate, where I think there's a private ship which was anchored, also got hampered, and I think there was some major accident also. So different cyclones, all these different. So these are all another very important impact of the climate crisis. The another is again the distribution of species. I'm talking about the marine species distribution. You will find because of this a lot of disturbance, because of the global warming and all this, there's an increase in temperature of the mean increase in the temperature of sea also, acidification pattern also. So you will see many species which were there at one particular locality, they have shifted now. Those species which were near the coastal region, now they are no more in the coastal region. They have now gone beyond the coastal region and gone in the deep inside. So the distribution pattern has also has been disturbed because of this. So another one is probably then there are other impacts also, like there have been a incessant rainfall. You see, there have been instances of cloud bursting. Lot of instances of cloud bursting are there in the Uttarakhand. You must have seen there are a lot of landslides. See, these are nothing but all impact of climate change. Please understand. Unless you restrict, this is what the Intergovernmental Panel of Climate Change (IPCC) has been recommending time and again. In every COP, it has been reiterated by the ecological scientists that we have to at all costs restrict the rise in global mean temperature not more than 1.5 degrees centigrade. Please understand this. So we cannot afford to continue to discharge different kind of emissions, whether it is methane. Again, methane has got almost 25 times more global warming potential than the carbon dioxide. But I'll also explain you why we often talk about carbon dioxide, but we talk less about methane. You know why? Why it is so? We often talk about only carbon dioxide, we talk less of methane. See, the reason being that the transient life, see, if it is anthropogenic, then the carbon dioxide lasts from 25 years to 100 years. If it is man-made, if through the burning of fossil fuel, this carbon dioxide which is emitted can last up to thousands of years. You imagine thousands of years it can remain in the system in your Earth's atmosphere. So you see the long impact, the long lasting impact, the carbon dioxide that is emitted through the human activities, that is going to last for so long. But whereas methane is concerned, CH, though it has got 25 times more global warming potential than carbon dioxide, but nevertheless, it's a transient life, or the self life in the atmosphere is much, much lesser than the carbon dioxide. Almost, I think it is almost 25 years to 30 years, the self life of methane. That's reason, and ultimately, when we say methane, whenever the methane burns, that also lands up into carbon dioxide, isn't it? So ultimately, the end product is carbon dioxide. So you will have to understand, you will have to differentiate the anthropogenic effects of carbon dioxide, at the same time the carbon dioxide that is emitted because of the human activities. See, you please understand that we use air conditioners so rampantly, and the amount of heat that is generated from the exhaust and the carbon dioxide, through the heat, that all contributes to the global warming, the exhaust heat. So you may not understand, but then it is having a very devastating impact. Then the next is a global, I wanted to bring point home to you this, why this coastal habitat or the marine ecosystem is important in comparison to the terrestrial. See, this oil, you see, the left hand side part is basically mangrove stem and mangrove upper portion. They are all responsible for the fixation of carbon dioxide. But the main part is their root. Root is the main part which helps in the fixation of carbon dioxide. And mangrove, as I have told you earlier also, this is a very good breeding ground, I am telling you, very good breeding ground for lot many species, I am telling you, lot many species. And I like to share one good thing about ONGC, that recently we have started a very good integrated project in Karaikal region, Puducherry district, where we are undertaking mangrove plantation in the area of 10 hectares of land. At the same time, we are doing olive ridley turtle conservation plan also along with that. So basically, it's not only this, we have basically developed a different kind of components, like the community which lives nearby, those community and particularly women. We have, through this project, we have developed a self-help group of women who will be contributing meaningfully towards this project. So this is basically a two-pronged project where we will be undertaking mangrove plantation. At the same time, we will be protecting, sensitizing all the communities, because see, this olive ridley turtle falls in the red list, in the danger list, of IUCN. So these different species also needs to be protected. So we have undertaken this. Recently it started in the month of August 2022, and this is a 3 years project, and hope this project should give a very good impact on that particular locality. So I always say that people should come forward and take more and more green initiative, so that you can reduce, you can mitigate all the different kind of risks associated with this global warming, these emissions. Then the graph you can see here, the seagrass, salt marsh, mangrove, oceanic mangroves, these sediment, these soil are able to fix this tons of carbon dioxide equivalent per hectare much more in comparison to the living biomass that is there on the terrestrial. See, you can see the green and you see the blue. So you can very well see this. Then again, as far as the restoration feasibility is there, in case of all, I'm telling you, see, as far as the resilience, you understand what resilience means? Resilience means basically, if it should be in a position to sustain in case of any kind of adversity. So if the circumstances are unfavorable to this, in even those adverse circumstances, if your marine ecosystem is so good that it has got a very good resilience capacity. it can very well withstand these kind of small disturbances, local disturbance. Whereas if you compare the terrestrial part, land part, you will find they are much less apt in handling this, in having this resilience. Next slide. Then coming to this, how we are polluting marine ecosystem as such. See, these are the different sources, how much they are polluting. You can see, I've just wanted to show you, what kind of percentage they contribute toward the marine pollution. These are the top 10 different contributing items like plastic fishing line. They pollute to the tune of almost 15%. The different type of plastic fragments, they pollute to the tune of almost 9%.
Summarize कर दो. You do.
So time to was both. I have got lot of materials.
But you.
See.
Okay, you take another 5 minutes.
Okay.
Summarize it and come give some suggestion policy.
Okay.
The session belongs to policy.
Since actually the students are there, I thought ki they'll be more happy and understanding the different kind of system. So I have kept you people in my mind, because I know, see, as far as the industry people are there or academia people are there, those who are teaching, they know, they read also. But to sensitize you people, if I am able to sensitize at least, the whole of the student community, I think I have done my task. I have fulfilled my task.
Thank you, great.
So these are the, again, glass beverages. So what I say, see, you must be knowing that single-use plastic have been banned by Government of India. I think regulation has already come in April 2022. And you see this single-use plastic, how much they are polluting this marine, almost to the tune of 50%. See, per annum, the amount of garbage that we are putting in the marine ecosystem is to the tune of almost 300 million tons. Plastic gets created every year. And you see, out of this 300 million tons, 70% of these all plastic debris, they come to the surface of the ocean. When you say the seabed, and seabed again is very important, very crucial, because seabed plays a very important role in maintaining the oxygen level of your atmosphere. So what do? You are doing almost 70% of your plastic debris are accumulating, depositing on the seabed, 15% are almost floating, and 15% almost lands on the sea beaches. I think you all must have visited a number of times sea beaches. You must have seen the amount of plastic garbage that is accumulated across all beaches in India. Now, again, plastic again, and then it comes again the microplastic. There is a difference between the plastic that we generate, single-use plastic, and the microplastic. Microplastic again is if your plastics are degraded because of lot of weather conditions, the ocean currents and all this, so they also get dissolved into smaller particles, which if it has a diameter, particle, if it has a diameter less than 5 millimeter, then these are designated as microplastics. Now, I'll again like to caution you all that please, for God's sake, stop using water from the plastics. The plastic containers that you use Bisleri and all this. See what happens when it is stored for for a long period of time. This water also, this plastic also starts getting dissolution, and that also come into a form of microplastics. Maybe, see, you never know how much time it has been there in contact with the plastic body. So, be a sensitized community, stop using plastics. See, these are also, basically you use it, you drink water and then you throw it. So, basically what you are saying, you have accumulated, you have used 1 liter of water and you have just thrown it. So, you have not seen how much harm we are doing to the environment. So please start using your own water bottles. I mean, that is why it is often said that recycle, I mean, you have to use and more recyclable products. I'll come on that also, 6R principles, I'll come on that. Then see what happens the moment these microplastics are there, I mean, with a lot of current, oceanic current forces, lot of disturbance and all that because of the waves and all this. So these microplastics basically enter in the food chain of this, because once they, see basically what happens, these marine creatures, when they breathe through the dissolved oxygen that is there in the water, when they breathe in the dissolved oxygen, when they get this microplastic also, when they inhale, so what happens, these microplastics get embedded in their tissue, in the tissues of these small creatures, marine creatures, and then at times they have tendency, they are not in a position, I mean particularly small creatures, they are not in a position to digest it. So because of ingestion, this again there will be high probability of ingestion, and see ultimately human also consume this. So ultimately whatever the garbage that you have discarded to the marine system, basically it is coming to us. So what basically our health is being impacted. So see, this is what I say, what you do, whatever you give back to the system, you will again take it back. So this is basically a cyclic process, isn't it? Then just because of you people interest, you please understand this ocean carbon cycle. See this ocean carbon cycle, I'll tell you, there's a very important, I think how many people know about the law of homeostasis? I think most of people, you must have read the first law of thermodynamics. First law of thermodynamics. Anyone can, other than the industry people, anyone from the student, what is the first law of thermodynamics? See, first law of thermodynamics, I think this is a very basic thing. Energy can neither be created nor destroyed. It can be only transformed from one form to the other. So basically what homeostasis, what is the law of homeostasis? Law of homeostasis basically pertains to the tendency of an ecosystem or any organism to regenerate, to restore through the process of dynamic equilibrium. See, this is the beauty of the nature, that all kind of ecosystem, all organisms have a tendency to revive themselves, even in case of adversaries. Even if you are creating adversaries, again you must have read the survival of the fittest. I mean, every organism has to change its lifestyle to accommodate to the adverse circumstances. So survival of the fittest was given by which scientist? Survival of the fittest, I mean those who will be able to survive, who will continue to remain fit.
Darwin.
Yes. So I may see basically why I am telling you these things, because this is also what I have read in class 10th, 11th, 9th, 10th, 11th. But then I am able to visualize these things with the daily practices. Until or unless you find a good connect between these two, you will not able to appreciate. So that's my way of thinking, my way of taking, I mean studying, understanding science. You should appreciate all the principles, and then you should apply, and then you should see how applicable it is in our day-to-day life. Once you develop that corroboration of what you study and what you see, once you start corroborating these two things, you will be able to appreciate in a much better way. So this is the ocean carbon cycle. Through this, again, carbon dioxide fixation takes place. These are the different process. I mean, breeding grounds are there. Then you will see the soil, sediments, all these are all play a very important role in fixation of carbon dioxide. So in nutshell, basically I wanted to tell you this ocean is basically, next. ocean is less sensitive to short-term disturbance. As see, there are a lot of waves disturbance are there, high intensity waves are there, but still, this ocean, because of its resilience capacity, it is able to sustain itself despite of this disturbance. However, when it comes to the land or terrestrial side, you will find they are disturbed very badly. See, that's the beauty of the marine system. Next. I think I have spoken enough about this different kind of ecosystem. I think you will appreciate this also, and I'll urge all the students to read more and more literature on the ecosystem, particularly the marine environment, different ecosystem which I have explained it to you, and you please build on this. And I'll share my mail also. You are most welcome. You can write n number of queries to me. I'll be happy to answer to your queries also. Now, being from the ONGC, I thought I must take this opportunity to showcase what all facility we have ONGC in place. So basically, as far as we have got both offshore activity as well as the onshore activity. Offshore means, activity which is there in the seaward side, and onshore is basically on the all operations that is restricted to the land side. So basically in the offshore we have got two kind of offshore activities. One is the western offshore and another is eastern offshore activity. So western offshore we have around about 14 process complexes. When we say process complex, means we handle crude oil, natural gas, different kind of gas dehydration units, and then LPG, LNG, these all different components of this, these are all handled there. And then we have got 229 well platforms. These process complexes are all always manned by the people, but there are around 229 well platforms which are not manned. People don't stay there, but every day the visits are undertaken by our workforces to check the different requirement of that area. We undertake different kind of study because productions are taken from the wells. So every time visits are undertaken, the wells are monitored, the flow is monitored. So these different things are taken. Then plus lot of studies are also undertaken, like pipeline corrosion monitoring is also taken. Then see, because since we take production out of the formation, sedimentary rock, the production of crude oil that we take, so we have to, in order to maintain the reservoir pressure of the formation, we have to inject water also. So we have to inject water also to maintain the pressure of reservoir. So that we lot of water injection is also done. It's not that whatever the sea water is there, it's not that the whatever sea water that we intake, that we inject. It's not like that. See, sea water also has to be filtered. That is filtered with we have got a system. Water injection platforms are there,
Salinity.
where we filter for the total suspended solids. Then we again do different kind of dosing of corrosion inhibitors, scale inhibitors, like sodium hexametaphosphates are added. Corrosion inhibitor, why? Because see, once this marine, about this sea water is very corrosive in nature because of this. I think you all must be read this. You know how this corrosion takes place? Any idea how does corrosion takes place in the pipelines? Sir, मैं 2 ढाई घंटा बोल सकता हूँ.
इंक्लूड करो लोग सुनने को तैयार हैं.
So, see, basically, I'll tell you what corrosion is. Please understand. Basically, corrosion is nothing but a electrochemical reaction. Electrochemical reaction means, see, there's an anode and one cathode. At cathode, basically reduction reaction takes place. What reduction reaction means? I'll tell you. What reduction reaction? See, the moment we say metal, so what happens at anode? And this metal is there at the anode. Basically, oxidation process takes place. Oxidation is what? You must have read loss of electron. Loss of electron is an oxidation process. So what happens? metal, these all metal surfaces, these metal leaves behind electrons and they become metal ions. And these metal ions, I mean, see, I said oxidation process takes place at anode, isn't it? So what do at anode, what see these metals get dissolved into metal ions, means M gets into Mn plus with the release of electrons. So basically what happens, whatever your metal is there, that is being dissolved in the system that you are getting in the liquid form. So basically you are corroding your metal. So because see the C as such has got a huge concentration of chloride ions, and chloride ions, I am telling you, they are the excellent sources of carrying out petic corrosion. Petic corrosion is basically a process of corrosion where they do the localized corrosion. I mean, they do a localized kind of, I mean, on the same location they keep on making holes. So what basically it does, this makes the structure very weak. I mean, you will find lot of holes coming on the metal structure as such. So marine ecosystem, again, until unless we do all kind of precautions, safeguards, I mean, we have to do the corrosion emitter. Corrosion emitter again plays a very important role. They form a kind of film that forms a film, and that film basically forms a barrier between the media and the metal surface. So that forms a barrier, so that restricts the metal to dissolve in the metal ions. So that is why I always connect. See, whatever you read, whatever you study, until unless you corroborate with the process of your, I mean, in your industry, you will not appreciate it. So whatever you have studied, you must correlate with them. Then we have got a huge pipeline network in the western offshore, almost 6,700 kilometers. We have offshore supply vessels, almost 46. Then we have a PSVs, main supply vessels, 7 numbers. There are 3 numbers are firefighting supply vessels. Then we have got a 25 drilling rigs, workover rigs. Then we have got a FPSO, that is floating production storage and offloading facilities in western offshore. In comparison to the western offshore, eastern offshore has got a, I mean, is a much smaller in a sense, because it has got only 1 process complex and 3 well platforms. Pipeline is almost 200 kilometers. It's just for you people to understand, I mean, what kind of facility that we have in the offshore. Next. Now, the very pertinent question that must be coming to you all, then how do you see a lot of production, exploratory development, drilling activities are being undertaken in the offshore? Then how do we manage the waste? Isn't it? I mean, the waste that we are generating, how we are managing this waste. So ONGC have got a very robust environment management plan. We have got a very incredible system, well within the rules of hazardous waste management rule is there, 2016. I mean, which tells about all kind of regulations, all provisions are there in this. So what happens, whatever the waste, particularly the hazardous waste I am talking about. Why I mentioned this hazardous waste 2016 rule, we strictly comply with those rules, and whatever the waste that are generated at the platform or the drilling rigs, these all generated are backloaded to our offshore supply vessel. See, offshore supply vessels, they come and hand over a lot of tubings, pipes, the food, I mean the food materials for the workforces, different equipments. These are all come from our Nava supply base through these offshore supply vessels, and we receive them. And after receiving all these equipments, whatever the waste that we have generated, these wastes are again backloaded to these offshore supply vessels, and these all offshore supply vessels take it back to our Nava base. We have got a good setup at Nava where all equipments, all facilities are there in place. So all these things are backloaded. It's not that our job is finished only after loading. So whatever the waste backloaded that we have waste, we send it back to to the approved recyclers. Now you'll be asking what is approved recyclers? These recyclers which have been already designated by their respective state pollution control board in their states. So these are all approved recyclers. We hand over to them for recycling. So see, the whole chain of is there. Whole chain system is there for management of these hazardous waste.
Rajiv, conclude kar do 5 minutes. 5 minutes you concluded. Ready sir will take half an hour.
Okay, sir. Okay. Then, as far as the see, this was all about the solid which I was talking about. As far as the drilling is concerned, in the offshore we carry out exploratory and development drilling. Then the mud drilling fluid that we use for this cutting and all that, that drilling fluid, I mean water-based drilling fluids. And again, in those fluid, I mean the drilling operation, there has to be a fluid which exerts weight on this, on the drill bit. This exerts weight on the drill bit, which drills the hole. So those, I mean the cuttings that are generated when you do the, when you make it hole, so these cuttings which are generated, that has to be bring back to the surface. So these cuttings, when you use this water-based drilling fluids, so these cuttings generated out of this, they are not hazardous in nature, because we make sure that whatever the additives that you use in the drilling fluid, these are all eco-friendly. Eco-friendly, and it's not that we say it is eco-friendly, because we have to again conduct certain kind of testing also. I mean the cuttings that generate out of it, these cuttings are also tested. When you do the drilling, we get it tested for the LC50, lethal concentration 50, that should be more than 30,000 ppm. I think you'll read, this is there in the guideline, you can see. So these things are there. Again, the most important for you all to understand the principle of 6R. 6R is again, you need to rethink. Before discarding, you need to rethink. First step should be again, as far as possible, you should refuse it, not to use a hazardous waste. If you are not able to reuse this, then you have to resort to the repair methodology. If it can be repaired, I mean whatever it is there in the use, if it can be repaired, or a particular chunk of this can be changed, I mean you reduce that portion instead of changing the whole as such, that waste part or the plastic part or whatever it is. So you can reduce the plastic footprint by using that particular local area as such. Then again, if it is possible, you can reuse it. If you are not able to reuse it, then that can be recycled. So 6R again principle is very apt, and we need to follow this. Drill cutting, I have said, water-based drill cuttings are again very eco-friendly. As far as when we do the oil-based, when you use oil-based mud or synthetic oil-based mud, because these are used particularly in the finer portion. When we do the drilling, the last portion of the drilling, I mean almost to the tune of 3 kilometers in the last zone, I mean almost around 3 kilometer zone, generally this synthetic oil-based mud or the oil-based mud, they are very good in drilling those kind of strata. So that is used, but then once you use these kind of drilling fluid, I mean synthetic oil or oil-based mud, we cannot, I am telling you, we cannot discard in the sea. See, water-based drill cuttings you can discard, and that also rule is there. It's not that you can, I mean you cannot discard at your whims. That has to be also discarded at the rate of 50 barrels per hour per well, so that it has got a sufficient dilution factor. I mean dilution factor means if you discharge so much of waste, the locality or the vicinity, the biodiversity in the vicinity of that area, that does not get disturbed. But as far as the oil-based synthetic mud or synthetic oil-based mud, we do not discard it. Whatever the drill cuttings that are coming out of it, along with the we always store it in a tanker. We have a designated tanker is there. Those have to be stored in the tanker, and there's again that has to be reused. I mean because you only use in the finer portions, the quantity is much less. So that can, again, that whatever the we recover after the removing of the drill cuttings, whatever the drilling fluid, oil-based drilling fluid is there, we again reuse it. I'm just trying to make you understand. I mean, whatever things we are doing, we are optimally using it, reusing it, recycling it. Then see, this is one beautiful things which I wanted to see. We are doing offshore operations. We are extracting oil from the formation. Almost, I think we started production in the Mumbai offshore, I think 1974, and production probably started in 76, 77. So, see, as a responsible organization, as a ethical organization, it becomes our moral duty to ensure that whatever the extraction of oil that we undertake from our offshore fields, we also ensure that we monitor those areas, monitor those things for the different kind of parameters. I mean, we measure the water columns, the biodiversity of that region, and you will be happy to note, as a very responsible organization, since 1994 in the Western offshore, we have been carrying out offshore environment monitoring, not by a very credible organization like National Institute of Oceanography, Goa. That's a part of CSIR, Central Scientific Institute of CSIR, sorry, Central Scientific Council. And then other credible agency like Vimta Lab and Detox Corporation, we have been doing since 1994 these things. And in the Eastern offshore, we have started in the year 2014 because our operations have started in 2014. And these are all monitoring, offshore monitoring is done as per the MARPOL and OSPAR, Oslo and Paris Convention guidelines. I'll quickly just share, I mean, these are the different parameters that we monitor, like hydrographical solids, chemical oxygen demand, biological oxygen demand, heavy metal analysis, hydrographical chemical, then hydrocarbon biological, total petroleum hydrocarbons, heavy metal analysis. These
Rajeev,
all different kind of analysis are there.
Almost
Yeah,
going to 1 hour, please.
Okay,
There is a limit.
and see, why I am sharing all this, because of once we have done this monitoring, the most important part is the interesting result, findings you see. The results are so interesting. See, whatever results, whatever the exploration development activities that we have been undertaking since long, we have been sure that we are not impacted. We have not impacted the offshore environment of our region. And these are some of the findings, like water columns have been studied, that their nutrition level have been found well in order. Then the health of the phytoplankton, zooplankton, through the measuring the biodiversity index. That is, I think, we measure in terms of Shannon-Weber index. So these are the different indexes that are measured, through which you tell about the health of the biodiversity of that. So all this, then benthic production, petroleum hydrocarbons have been also measured, total petroleum hydrocarbon. See, as per the rule is, in offshore, as per the MARPOL guidelines, it should not exceed more than 15 ppm. And as per the law of the land, the discharge should not exceed more than 40 ppm, that is 40 milligram per liter. But once we have taken this offshore monitoring study by this credible organization, they have shown that the this total petroleum hydrocarbon content is much less and is almost below detection level. So I think ONGC deserves a big round of applause for maintaining a good offshore health. So with this, I think I'll end up here, and if possible, if time permits, maybe that I'll share more things with you. Thank you so much.